let's jump right into a question that sounds so simple you've probably never even thought to ask it. But the answer? Well, the answer takes us on a 400-year journey through the history of astronomy, and we'll meet some of the greatest minds who ever lived. The question is this: why is the night sky dark?
Now, to get why that's even a mystery in the first place, you have to try and wrap your head around the sheer, mind-boggling scale of everything. We're pretty sure there are more stars out there in the cosmos than there are grains of sand on every single beach on this planet. It's a number so big it's almost meaningless, but let's try to picture it.
Okay, so imagine our sun is just one single grain of sand. If that were the case, our galaxy, the Milky Way, would be a hill of sand made of 200 billion grains, and it would weigh something like 800 tons. Now here's where it gets really wild. There are at least 200 billion other hills just like it out there in the universe. That's how many galaxies we think exist.
And the universe is just absolutely jam-packed with them. I mean, when astronomers pointed the Hubble Space Telescope at what they thought was a totally empty, pitch-black patch of sky, an area smaller than a pinhead held at arm's length, they were completely blown away. After letting the light gather for days, they found it wasn't empty at all. It contained nearly 3,000 entire galaxies, each one with billions and billions of its own stars.
Which, of course, brings us right back to our paradox. If there are countless stars in every single direction we look, shouldn't all that light add up? Why isn't the whole night sky, from horizon to horizon, as blindingly bright as the surface of our own sun?
So this puzzle actually has a name. It's called the dark sky paradox. And to unravel it, our journey really has to start more than 400 years ago, with a simple but totally revolutionary idea about how the universe is put together. Our path to the solution has 4 really key stops. We're going to start in 1556 with the guy who accidentally created this whole problem. Then, we'll jump to the late 1800s to meet the woman who gave us the tool to solve it. From there, we go to the 1920s for a discovery that shocked everyone, and we'll finish up with a little story about Albert Einstein himself. Okay, so here's the crucial first piece. For centuries, everyone followed the model from Copernicus, where the Earth and the planets were surrounded by one single final sphere that held all the stars. It was neat and tidy. But then, in 1556, an English astronomer named Thomas Digges made a tiny little change to a drawing in that book. He erased the outer shell and scattered the stars infinitely, in every direction forever. And with that one little edit, he unknowingly created our paradox. Later on, this problem became known as Olbers' paradox, and the logic seems totally airtight, right? If the universe is infinite, and it's unchanging, and it's been around forever, then no matter where you look, your line of sight has to eventually hit a star. The whole sky should just be a solid, blazing sheet of white light. But it isn't. So something in that logic had to be wrong. To figure out what was wrong, astronomers needed a whole new tool. They knew the universe was big, but they had no clue how big. They couldn't measure it. What they needed was a cosmic yardstick. And this really gets to the heart of the problem they faced. When you look up at a star, you can see how bright it looks to us here on Earth. But there's no way to know if it's a dim little star that's really close or a super bright giant that's incredibly far away. They could look exactly the same. And if you don't know a star's true brightness, you have no way of knowing its distance.
And this is where the hero of our story really comes into the picture. The person who cracked this problem wasn't one of the famous male astronomers of the time. It was a woman whose incredibly detailed and patient work would completely change how we see the universe. Henrietta Swan Leavitt.
So Henrietta Leavitt started working at Harvard back in 1893, in a time when women weren't even allowed to use the telescopes. They were hired as computers, and that was their job title, not a machine, to do all the brutal, tedious calculations by hand, analyzing photographic plates. And for a while, she did this crucial scientific work for free. Her job was to catalog a special kind of star called a Cepheid variable. These stars pulse, getting brighter and dimmer with a perfect rhythm. And as she was poring over thousands of them, she found a secret hidden in the data. She realized that the speed of a star's pulse was directly connected to its true brightness. The brighter the star actually was, the slower its pulse. This was it. This was the breakthrough. All of a sudden, astronomers could look at any Cepheid in the sky, time its pulse, figure out its true brightness, and then, by comparing that to how dim it looked, they could calculate its exact distance. She had found it, the cosmic yardstick. And Henrietta Leavitt's discovery, it wasn't just some clever trick. It was the key that unlocked the next huge secret of the cosmos.
It revealed that the universe was anything but static.
So armed with this powerful new way to measure distance, an astronomer named Edwin Hubble started mapping out the universe. He used these Cepheid stars to prove that all those fuzzy smudges we saw in the sky weren't just clouds in our own galaxy, but were entire other galaxies, just like ours, millions of light years away. But that wasn't even his biggest discovery.
As Hubble was measuring the distances to these galaxies, he was also measuring their movement. And he found a pattern that was just shocking, a pattern that held the key to this whole mystery. Pretty much every galaxy was moving away from us, and the farther away a galaxy was, the faster it was moving away. The universe wasn't just sitting there, it was expanding.
Now, to be super clear, this doesn't mean that all the galaxies are flying away from us through empty space. The reality is actually much weirder. The very fabric of space-time itself is stretching, and it's carrying the galaxies along for the ride. The whole universe is getting bigger.
And that one discovery, that the universe is expanding, is what finally gave us the answer to that 400-year-old question. It gives us the two missing pieces of the puzzle that completely shatter the logic of the dark sky paradox.
First off, if the universe is expanding now, that means if you run the clock backward, everything must have been way closer together in the past. It means there was a beginning. And using the rate of expansion, we can calculate that this beginning happened about 14 billion years ago. So the universe is not eternal, it has an age.
And that leads us straight to the answer. Ober's paradox assumed an infinitely old universe, but ours is only 14 billion years old. Light is incredibly fast, but it's not infinitely fast. The reason the sky is dark is because we are looking at an unfinished picture. The light from stars and galaxies beyond a certain cosmic horizon has been traveling toward us since the dawn of time, but it just hasn't had enough time to get here yet.
Now, this idea of a dynamic universe, one that had a beginning, was so radical that it wasn't accepted right away, not even by the greatest mind of the 20th century.
You see, Albert Einstein was so convinced that the universe had to be static and eternal that when his own beautiful equations of general relativity suggested it should either be expanding or contracting, he just assumed his math was wrong. So he invented something called the cosmological constant. It was basically a fudge factor he just stuck into his equations to make the universe stand still.
But eventually, Einstein traveled to visit Edwin Hubble. He looked through the telescope himself, he saw the evidence with his own eyes, and he admitted he was wrong. He later called that little fudge factor the biggest blunder of his life, and you just have to look at this photo of the two of them. I mean, the sheer, pure satisfaction on Hubble's face says it all. Can you even imagine that conversation? What did you do today? Oh, not much. Just proved Einstein wrong about the universe.
And that, to me, is the real magic of science. It's a process. It's this incredible human story full of geniuses and unsung heroes, of brilliant ideas and gigantic blunders, all of them building on each other to get us just a little bit closer to the truth. Which really just leaves you wondering, doesn't it? What fundamental fact that we all accept is true today will turn out to be tomorrow's great corrected mistake?